Okay, let's begin for today. So today this is a list of topics I was going to basically do. So we might talk a little bit more about while loops, maybe even do some while loop and for loop merging, nested while loops, nested for loops, that kind of thing. And then we can do some string methods. So you've already seen split, but this is the lecture where I'm going to officially talk about strip, split, join, in, and not in, and then using strings as arrays. And so we'll learn a bit more about strings today, and maybe, I guess officially, we'll talk more about concatenation too. So that's all pretty good, right? Okay. So let's see what we've got. Here it is. Okay, there we go. Let's make another while loops and strings, so we'll do while and string. So here's our new file. Okay, so let's begin. Let's actually move the microphone a little closer. Alright, there we go. Okay. So last time we talked about while loops. So remember, while loops are like if statements. Statements on repeat, right? So for instance, if I say, here's a common problem that we give where we say x equals, say, int input, telling me some integer. And then what we'll do is we'll say while the integer is bigger than 0, and then we'll have maybe a count variable. And then we'll say, okay. And then count plus equals 1. So what is this example doing, right? So what this is doing is it's going to divide x by 2 using integer division, and it's going to increment count. So every time it divides x by 2, count goes up by 1. And so now let's print out, say, the count, right? So if we enter, say, 16, hopefully 4 will come out, maybe 5. Let's see what happens. 5. Okay, so it's a little too big, but it's okay. Maybe we'll do it, well, that shouldn't matter, right? Anyway, and now let's try, say, 32. Should be 6 in that case. And it should, let's try, 64. It should be 7. So what do we notice that's happening here? So what we notice is that each time we go up by a power 2, the count increments by 1. So actually what it really is if you notice that 2 to the 6th is equal to 64, this is spitting out 7 because it's 1 bigger. We can always just subtract off 1 from the count if we're really, if we want it to be correct. So we could do something like, tell me an integer, let's say 128, that should give us 7. 256, 8. 16,384 should give us what? 14? Yeah. Okay, so here's the point. This is a little discrete log calculator, right? This is a discrete log calculator. So if you've ever really wanted to compute and what I mean by discrete log is that it's basically rounding down, or is it rounding down or rounding up? I guess it's kind of rounding up the log of a number. So it's not asking for the actual log of that number, it's asking for an approximation as an integer. So if we entered in something like 384, well, I don't know why I'm picking such numbers that are so close to powers of 2. Let's pick something like 91. Let's see what this gives us. It's either going to give us 6 because it'll give us 64's power, or it'll give us 128, which is 7. So let's see what happens. Okay, it gives us 6. Cool. I guess that's because it's doing the count minus 1 here, so it's rounding down. This is the count minus 1. Anyway, so this is a use of a while loop that's not actually... So this is something that's different, right? This is not for input validation. This isn't for... this isn't for anything but, just some kind of mathematical process. But it's interesting because it's a while loop because it's hard to. The thing is, you don't know what the answer is to the math problem before you actually do the calculation. Now you could always, use the math library and just take the logarithm. But the point is that actually, this little process here is going to be whatever it's doing to calculate the logarithm. This is going to be way faster. Way faster than actually calculating a log. And the reason why is just because actually calculating a log to, to various decimal digits requires effort, right? And it either requires like a Taylor series probably, or some other kind of method. Right, so, okay. So let's do another while loop example before we move on to strings. So let's think, so let's nest some while loops now, okay? So let's say that we want to keep finding the logs of numbers until we want to stop. So basically, we'll say while s is not equal to quit, right? Our standard thing, and I'll use a dot lower just so that I can save myself from any embarrassment. So let's stick all this in here. Let's push this in by 1. So now we have a nested while loop. We have a while loop within a while loop, right? And tell me an integer or quit, right? So here we're going to use s as a string, and then what we're going to do at the very end is, or I'm sorry, well here what we're going to do, let's see, where do I input the integer? Oh, here. Okay, let's take that out, and then here what we're going to do is we're going to set x equal to int of s, right? So the only string you're allowed to enter is the string quit. If you enter anything else, then it's going to give a value error and fail. But if you enter in, like, well, let's just show the program running. So let's say we entered 5. Okay, cool. We enter 17, we should get 4. Enter 31, we should get 4 again. Enter 123, some number. And okay, so that's about 2 to the 70th power apparently, right? And then here, right, so every time we do the calculation, this is the inner while loop here. So the inner while loop runs every time we enter a number. But now that we're going to enter, I'm going to try to enter quit. Let's put in capital quit to see what happens. Hit enter. So now what you see that happened is that this time that we went around the outer while loop, it checked that s.lower was equal to quit, and it said, oh, you're equal to quit. So let's get out of this loop. And that's what it did. So it did not enter this loop. Now you see that there's a little bit of danger here, right? Because if you enter something else, this will give a value error. So for instance, if I say continue, right, it's just going to give me a value error because it's not going to like that. If you type in anything other than quit or a number, it will yell at you, right? So, and currently, as I say, this is definitely, this kind of thing is okay for you right now. Okay? So maybe I'll tell you how to protect yourself against it a little bit, and then maybe we'll actually start doing that. But for now, it's okay. If we tell you to make a program where the program wants to accept an integer, and then we type in a string and it fails, that's not on you. That's, we'll definitely make sure that all of our input types are correct. So, okay, so here's an example of a nested while loop. It's kind of contrived, but, it does the job. This is kind of how a lot of games and stuff work. where you have a while loop that runs the game and then another while loop or another for loop or some kind of thing on the inside that does other kind of game calculations or something like that. So, okay. Let's begin. So for now, let's leave while loops alone for just the moment. So this is a good example of a while loop, but yeah, let's talk about strings. So let's get back into strings. Okay. Yep. Okay, so let's talk about strings, and then we'll do while loops. We'll mix while loops and strings together a little bit. So, okay. So what are the things that I want to teach with regard to strings today? I want to teach strip. I want to teach split. I want to teach join, and I want to teach some other stuff. So using strings as lists. And what was the other thing I said? Let's check. Oh yeah, the in and not in keywords. So those are important, right? Okay. So, all right. So what does split do, right? Let's just start with split because it's at the first thing in the list. So, you know, what does split do? The answer is, oh, I'm sorry, what does strip do? We already know what split does. What does strip do? Strip will take a string and nibble off all of the white space before and after any characters. So what I mean by that is that it's going to, it removes white space basically. So if you have any leading or trailing white space, say goodbye to that. So let's do some examples. What exactly are methods? That's a great question. The answer is that methods are anything that... Yeah, so let's talk about... I'll just define a method. A method is a bit of code that runs... basically, it's a bit of code that runs in its own kind of space. I shouldn't say that. I mean, what am I actually going to say? A method is a function, which I haven't defined, which runs in a kind of, which has its own variables, code, and sometimes returns values to us. So I think that's the best way to describe it right now. Functions are... Let's see, when do we teach functions? We teach functions next week. So basically, I'm using functions here, but we're not defining them. If you've ever seen me use, for instance, like a def my function, and you can say print hello there, right? And then, for instance, if I call my function like this is basically, so let's just type quit, and then you see here, I called this method here, and it ran this bit of code. And so it's a way to kind of template your code so that you have little bits of functionality that runs separately, and you can even pass stuff in and do all... There's all kinds of stuff you can do with it. But this is basically next week. Okay. But right now, all we're doing is calling methods. We're not writing methods yet. That's next week. I know I'm like not really explaining it completely, but I don't want to explain it completely because, as I say, not yet. So let's use the method and just see what happens. So basically, strip is going to eat off all the white space. So let's see what happens. Let's make a string. Here's some spaces. Here's some tabs. Here's a new line, and then we'll say hello there, and then we'll even put a tab in here. right? And then we will maybe put some extra white space, maybe some new lines, and then the letter A, just so that you see, or like, we'll just put the word end here. So test string is going to be equal to this, and then what we're going to do is we're going to print out the test string, and then we'll print out the test string dot strip, and we'll see what happens. Let's do my standard if false business, right? Just to protect us from running any of this code. Okay, let's run it. Cool. So what happened here? Oh, well, okay, let's take the end off and see what happens. So, okay, let's look at what happened here. So here we have a bunch of, if you actually do this, we'll see you have a space, 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 space. Oh, and then this is not a space anymore. This is a tab. Then we have a tab, and you notice that the tabs here are not all the same width, but that's okay. They're all doing some kind of tabbing operation, right? And I know you're just watching me as I scan through white space, but that's the point here, right? All the white space is being currently rendered, and then we have a new line, right? And then you get to the meat of your text. You get hello, and then there's another tab here, and then there. And then we have what? We have some spaces, right? Here's all those spaces, and then we have a new line and a new line. Okay, so what happens? So this is what happens before the thing is stripped. You get all this crap. Now what happens after the thing is stripped? Well, you see here, you have hello with nothing before it, no spaces, no nothing. All of this is, well, what we could do is even print out, we'll print out an end character here to show where the string ends, because it's hard to know where the string ends unless you see something. There we go. So now you see here that at the end of the string, it's not going to print out that extra new line. It's actually just going to print out this pipe, right, the bar. And so here we see all the white space, and here we see the bar that the print function printed out for us. And then it starts printing out the next string, which is the hello there. But now you see that there's a bar here and there's a bar here, which means that there's no extra white space. Well, so here's the thing, like so you're not going to really have new lines at the end of your strings most likely, because if you ever use input, right, tell me something, right, and you do something like this and it says, you know, tell me a story, and you say, once upon a time there was a programmer who lived in a shoe, or something like that. The point is that as soon as they hit the new line character, they don't actually get to hit the new line character doesn't get added to the string. It just gets pushed to the input stream and then ends the input prompt, right? So generally you don't have that, but you will. It is totally possible, right, to have a bunch of spaces and even tabs and random characters, and, well, you know, can happen before input, right? And so it's definitely possible that someone will do something like this. So it's always good to just know how strip works, because sometimes what you want to do is you want to make sure that none of that extra white space gets taken, especially if you know, there's a lot of reasons why you might want to get rid of the white space. For instance, if you're going to stick it into like an int conversion, let's see what Python does with this versus right, these two things. Let's see what happens. The story is ASDF. So actually Python so interestingly enough, Python did strip this white space out. So sometimes you're safe, but I wouldn't feel very safe here. I would definitely strip it before I put it into an int. Just because I've seen Python do some odd things if you don't have it. But I guess this actually worked, right? Because it didn't give a value error. So it worked. Yeah, but anyway, so strip will definitely remove stuff from beginning and end of strings. And it's useful, especially if you're doing, say, file editing and file, well, I shouldn't say file editing, file input output, right? Where there are going to be extra new line characters all over the place, and you have to deal with them. And I'll explain that when we get to the file I/O lecture, but yeah, basically, when instead of the version of input for files, when you read a line out of a file, it doesn't strip the end line character out. So that creates like lots of issues that you have to handle. Okay, so that's what strip does. Strip is not that complicated, but all you have to, the one thing to remember is that if you strip, you have to assign it to a new variable. So for instance here, if you do something like myString is equal to myString.strip. If you just did, for instance here, if I just printed out the test string again, with end equals, like say this again, then you'll see once I enter the story, ASDF, the string hasn't actually been modified. And the reason why the string hasn't been modified is that a dot strip will output a what will it do? It will output a new string, and so you need to set it to a variable. So what I mean by that is, for instance here, let's actually try this. I think this might work if we do new string equals something like this, and then we can do dot strip, and then actually you can stick. There's a secret character. If you put a character in here or a string in here, you can actually strip that thing off. In general, you don't. You know, most of the time you're just stripping white space. This is kind of a weird example, but here it is. So if you print out the new string, let's see what happens, right? Yeah, so it doesn't only remove white space. Hopefully it's going to remove all these A's. So let's see what happens. That's right. So this is how to do it. So yeah, if you have all these A's on the front and the A's on the back, and for some reason you really want to get rid of the A's, then you can strip off all the A's like that. Now, you might think, why would I ever want to do this? And the answer is, I have no idea. But, you know, you can definitely do this as well. So strip also works if you put a parameter into it. So the thing inside is called an argument or a parameter. And basically, the thing about it is that it is a, it will then strip that instead. So there you go. So you can strip other things. Okay, cool. So that's basically the functionality of strip. I mean, it's not that complicated. I think it's pretty intelligible. So let's go over split again. So split's the one that I think really is going to get used a lot. So, and the reason why split is the really useful one, so strip is good, but split is even better. And the reason why I think split is the best one is that it reads basically characters and splits on white space blocks. So I've shown you guys how this kind of works previously. But let's do it again. So if we just have a regular sentence, right, so here's a sentence. And so now what you can do is, say you want to get all the words from this sentence. And that's the stupidest variable name ever because it's kind of too long. You could just have sentence words or whatever, but I'm doing it for amusement. Dot strip. dot split. I always get them I always say them mixed up, but basically you always want to split when you want to split them up. So let's see what happens here. Print words from this sentence, and let's just see what happens. Guess we'll actually have to see the input again. Story is ASDF as usual. So a regular sentence, nothing special to see here, right? You know, that's a decent question. The answer is, who cares? Right, so I don't know. I just made it words from the sentence. So, okay. Now, if you actually, so here's a little bit of an extra thing. I think, let's say now, strip each word for the commas and periods at the end, right? And say convert it all to lowercase, right? So a lot of times, you know, if you're going to look up a word, if you have, say, some kind of, you know, storage for words that you're going to look up, if you're doing some kind of, you know, natural language processing or whatever, you don't want these extra little grammatical marks like periods, commas. You know, you want everything in lowercase probably, just so that the word a and the word a, right? Because technically a and a are different characters, but they're the same word. So how would we do that? So here's how I would probably handle it. I would say for I in range len words from this sentence. And then what I would do here is I would say, okay, well, I want them all in lowercase, so I'm going to take words from this sentence, I dot lower, and then I will strip off, and I think you can put a string in here with multiple characters. Let's see if this works. And then what I'll do here is I will assign it back into this. So this is why you shouldn't make variable names quite this long, because obviously it's starting to get long. But what this is doing is it's taking the ith word from this list, it's converting it to lowercase, and then it's going to strip off periods and commas, and then it's going to stick it back in here. And so then we're going to print out the words from the sentence again to see what happens, just to hopefully check out to make sure it worked. There we go. Wonderful. And it did actually strip off the period here, and it stripped out the comma here, it stripped out the comma here. So if you put multiple characters in there, in this, what it does is it strips for all of them. So I guess what you could do is you could basically, if you did something like, and then you did dot strip, say AB, so you can't put a list, I don't think you can put a list in there. So if you notice, when I do, for instance, like some string dot strip, like this, the first argument is self, which you kind of have to ignore. And then the second argument here is characters. And it seems to be telling me that characters wants to be a string, or maybe that's the return type. But this is a hint to me that probably strip takes a string, but let's try and put in a list and see. I think this might give us a problem, but what is it doing? Optional string got list string instead, so it doesn't like this. It probably has a type hint. So let's see what happens here. Locations of characters, like with strip. Yeah, I mean, I think, what do you mean by at locations of characters? So the first thing I want to say is that if you notice here, I have this ABAB abababa string, and I've stripped off A's and B's, right? So it doesn't matter that it's just stripping AB, it's literally stripping all the A's and all the B's, right? So this is going to result in an empty string with no A's and no B's, right? So it's not just, so if you want to split it indices, that's what we'll do with slices, so that's later. Split cannot split on indices. It can only split on elements. And so what I mean by that is, for instance, like with the phone number example, yeah, you could do that. You could say, something like hello, yeah, I'll just use your example. A fiend dot split a, yes, print. This should definitely work. You're right. The story is always ASDF. I think when, once upon a time in a galaxy far, far away, roll credits. So notice what it does here. So you see hello A, there A, friend. And you split on A, it'll definitely do that, right? Yeah, if you wanted to remove all the if you want to remove all the A's, B's, and C's, so it doesn't remove all the letters, right? So let me show you an example of where it's not going to remove everything. So if you do something like this, and you put some C's in here, now I'm not going to strip off the C's, I'm actually going to leave them in. So then what you see is it's going to start here, and it's going to scan until here, and then it's going to remove these so let's just watch it do it. So notice here how when it's stripped, it stripped off all the A's and the B's from the start of the string until it saw something that wasn't an A or a B. And then it went from the end of the string until it saw something that wasn't an A or a B. So it deleted this part and it deleted this part, but it didn't delete anything between the two characters. So even if you have A's and B's inside, it's not going to remove them all, right? So that's what it does. And I suggest. So I think the best way to learn this kind of stuff, I'm showing you how they work, but I think the best way, obviously, is to play, right? Definitely open up PyCharm or Emacs or whatever, and just try stuff out until you understand, right, how it works, right? There's no like 100% rules here, right? This is just how Python implemented this one function. So if you think, well, does the function do it in this way? As some of the people are doing here, come up with examples, right? Make yourself an example, try it, and learn from it, right? That's exactly, that's exactly how to play this game, right? That's how you really learn to do any of this coding stuff, is you just, if you say, I don't know if Python does it this way, what you do is you plug it in and you see if it breaks, right? So be curious, run into problems. It's all good, right? Okay. So I think you can split on more complicated things too. So there's some weird stuff you can do with split. So if you say, to hello B, hello, or hello, not hello, to hello, B, hello, that, hello. Right? Is. So you might say, well, that's a horrible string, and I think we can actually split on hello. So let's just see what this thing does. So there we go. To be or not to be, that is ... right? So you can split on it doesn't split on the H's, it doesn't split on the E's, right? So it's different from strip in the sense that the argument that we pass into strip will be, it looks, what should I say? It looks at each character individually. Whereas the argument in split takes an entire string and splits on that. So for instance here, there's like, is there an E? So here there's an E, but it didn't split on this E, right? There's, let's see, are there any L's? I don't know. Kind of weird stuff. So you can split on words that are not single letters. So this is a general string you can split on. You don't have to just split on a single letter. This is definitely helpful, for instance, if you have some file that's encoded that you know that, for instance, a number, like if you have, say, a person's name, so like Eric, right? And then say, you know, a colon and a tab, and then say you have, or, you know, a tab, and then, you know, maybe a 443, 343, 3434, and then another tab, and then you have his home address, which is 1334 Somewheres Lane, and then you have another tab, and then you have, say, you know, his email, which is, you know, something at something dot something, right? So, and then if you split this, for instance, on tabs, this is a very kind of useful, helpful way to do stuff, and you're probably going to end up having to do this. This is great for file I/O, because tab characters are something, you know, you can use tabs or commas if you have like a comma separated file or a tab separated file, right? And so this is kind of a useful thing. This is definitely not a terribly useful thing. This is a bizarre example, right? The above thing is a pretty bizarre example, but that's what it does, so there it is, right? Okay, so we've learned, at this point we've learned to strip and split, and of course you'll, you know, probably confuse them, but just remember, split is the thing that does the split, right? This converts a string to a list, this converts a string to a new string without trailing and heading whitespace. And this one, what does join do? So let's go to join. So join is a different one. So join is the opposite of split, meaning it takes a list and a separator, and I'll explain what I mean by a list and a separator, and list of strings, hopefully, and it joins them together. So for instance, let's do an example where let's say print out, let's shove all this stuff into a tabbed, that if false block, so that nothing else happens. Let's join together, what should we join? And here's the syntax. So it's kind of backwards, it's counterintuitive, maybe. Right? Counterintuitive is not one word? I thought it was. Okay. I'm like 80% sure counterintuitive is a word. Yeah. Python's dictionary just didn't have it. Okay. Or PyCharm's dictionary, I should say. Anyway, so let's watch what happens if you do this. So notice here, it's just smushing everything together. And the reason why is this string at the beginning is what I call the separator, which is, I think that's what they call it too, but it's the separator. So what that means is that what they're going to do is they're going to take this empty string and they're going to put it in between each one of these strings when it joins them together. And so you might say, well, I hate that. I want a space in between. Well, what we can do is change the separator from an empty string to a space. And so here we go. Let's run it. There we go. So now we have the thing that you probably think is the most intuitive way to do it. And the reason why I say this might be counterintuitive is because you might expect it to be list.join sep, and that is what some other languages do. For instance, I think Ruby does it that way, basically, but Python does it this way. It's the format is separator dot join list of strings, right? So that's the way that it works. And I promise you, you will screw it up, because even I've screwed it up a number of times. Because it's, as I say, it's counterintuitive. It's a little bit backwards from what you might expect. But you'll get used to it, and eventually you'll just think, okay, that's all it is. You can join things together. So for instance, you can put much more. Can you tell it to join every other string in the list? You can, but that's, I'm going to say not really. You have to do a little bit of extra stuff to get that to work. So, okay. You could do it, but it requires slices. Yeah, you can do that too. So, I mean, of course, anywhere where you have something that's this is like a list literal, you can also just use a variable name. So if I have my list of strings equals, say, you know, what's a good set of strings? String, rope, bind, tie, wristband, I don't know, scrunchy. Right? So there's a bunch of words. Jenga, whatever. I don't think that's right, but very little. Well, okay. So, so yeah, you can always do something like, and you can do really weird things too. So the separator is a general string. So, so you can do something like this. Yeah. So this is gonna look really awful. Well, actually, let's take general string out here and put in GS dot. Let's put some dots on both sides and just see what happens. So you notice that what it's doing is it's literally taking string and then the separator, which is .gs dot, and then rope .gs dot, bind, right, .gs dot, tie, .gs dot, etc. So you see that what it does is it literally puts whatever you type in here, and you can, you know, whatever you type in here, it's going to join it together. So you can make some pretty horrible looking strings with it, right? I suggest not doing that. I suggest, you know, at best, you know, you can put tabs in there. If you can even put something like, you know, you can say input, what is the separator, and let them type in sep equals this, and you can do sep.join this. So what is the separator? The separator is going to be happy face. There we go. So basically these things are pretty general. So the other way to think about it is that let's say that you have a phone number, right? So say 443 99 well, it's 910 1234, and let's say that we're going to split it on the hyphen, right? So this will split the thing on the hyphen and give us a list. And oh god, you see, you can make some really terrible stuff that we're just going to ignore how terrible that is. But you see that this thing was made by doing string, ASDF, rope, ASDF, etc. Anyway, so this thing is split now into three parts. And the point here is that you have a list that's made up of three parts. Let's say now you want to join it back together. Here's like a common trick, maybe, that you can do. So you can say that, oh, I have this list now. So what I can do is I can literally just do, say, period.join this list. And instead of having hyphens between the strings, you'll replace it with, so instead of hyphens between the strings, now you have dots, right? So if you ever need to separate a string and then rejoin it, so for instance, if you ever have a string that's separated by tabs and you need it to be rejoined by commas, so let's just use the Mary had a little lamb equals Mary had. Well, actually, we can do it twice, right? Like as snow, and now I'm in the Psycore. So what I can do here is I can split it on space. Well, actually, I don't even need to split it on space. I can just split it regularly. And then what I can do is I can say rejoin it with tabs and print it out. Now you might say, well, why the heck would I ever want to do this? The answer is there are reasons, right? So the separator is going to be sep. And so here you see that now instead of spaces between each letter, it's tabs. Now, of course, here, remember that so this is one of the reasons why tabs are a little bit weird, is that here apparently there's like tab stops. So this tab stop goes from here to here, but then I guess this tab stop was right here. So regardless of, so if we had tabbed from here, it would have gone to here, etc. So this is not actually a space. This is a tab, right? So if I copy and I paste it, okay, it doesn't paste at all. Oh well. Why doesn't it paste a tab? That's silly. Let's open up a notepad. And I think, let's see if we can paste it and see what happens. So you see that I copied and pasted it, and it pasted it as a tab, not as a space. So that thing is not actually just a single space. This is a tab, that the next tab stop is right here. And then here's a tab, then here's a tab, then here's a tab, then the next tab stop is a space, etc. etc., etc., etc. So that is, they are all now tabs. And you might say, what's the point of this? And the answer is, I don't know. But we need examples to use. And so this is a very common thing to do, where you split on one thing and you join back on another thing. So for instance, if we wanted to put, say, commas between the words, this is definitely something you might do if you were going to put this all into a, if you're going to put this all into a file or something. So anyway, but these are basically the strip, split, and join operations. Join is really the most confusing one, I think, because it takes a list and it makes it back into a string with the separator. And if the separator is something complicated, like a long string, then it just absolutely looks horrible, right? Right, like this is the result of a join operation, and it's not pretty. So be careful with your joins. Make them look good. Don't do that. Okay, so what else do we want to talk about today in terms of this? So we've done strip, split, and join. So this will convert a list of strings back into a single string with a separator. No, not with a spear. Separator. There we go. Okay, so let's talk about in and not in. So this is... So for instance, in this case, so the keyword, the Python keyword in can be used both with lists and strings. Technically also with dictionaries, but we haven't learned what a dictionary is yet. That's right, you can... So, oh, good. What does join do if there's one thing in a list? That's a good question. So argle bargle dot join single thing, right? Well, let's just print this out and see what happens. So as you notice, it just prints out that single thing as a string, right? Or doesn't print it out, it joins it as a string. And because there's not two things, it doesn't, right? It doesn't put the separator in. So the separator gets ignored if there's just one thing. But if there's two things, then it'll stick the separator in. So let's make this one thing And then you see that it'll stick the separator in here, but it will not stick the separator in there. Okay. So what does in do? The good news is in does exactly what you think it should do. And let's see, what should you think it does? What it does is, let's say that we are checking, so printing if C is in except, right? So the answer is true, right? C is in except. And let's actually just get rid of all this other stuff now. Okay. And then let's print C in failure, right? So C is in except, C is not in failure, right? So it returns false. So this is a great way to, and it doesn't just test for whether a single character is inside of the new string, it tests if a substring is in there. So what do I mean by that? Right, say math in, say polymath, and then for instance print math in physics, right? So let's see what this does. So these first two are for accept and failure. So math is in mathematics, so true. Math is in polymath, so true. And the string math is not in physics, so false, right? So let's do some other examples. Let's say that we have, is ABC in absurdic, which is not a word, but whatever. Well, it's for a lot of things, right? So it's, I mean, yes, you're going to use it to check things, but the general point is that you can use this. There's a lot of applications, you know, for this kind of. So I'll do another example with lists in just a second. So is ABC in absurdic, right? And now here's the, does it only return true and false? Yes, the in operator is a Boolean operator. So we would call it the in operator is a Boolean operator, which means it returns true or false, right? That's all it does. So, okay. What about this last example, right? What about? And the answer is that it's going to return false. Now the question is why? Because you see AB is here and C is here, so ABC is inside the string, so why doesn't it return true, right? So this returns false. But why, right? The letters A, B, C are all in there. And the answer is it's not testing for individual characters, right? Yeah, so that would actually turn out to be false, right? So hopefully that's a true statement, but whatever. So it's not testing for individual characters. It's testing only for substrings. And so by a substring, I mean completely something where, yeah, exactly. It's looking for A, B, C in order. So, you know, unfortunately, this is the one word I can think of. Is it just one? No. Wait, what? Why doesn't? Have I misspelled it? Do I not understand? Just. Oh crap! There's an S in there. A B let's see, is that how you spell that word? Damn, there's an E in there. I'm really trying to think of an ABC word. There we go. That'll come out true. Not. Yeah, is that a word? I mean, it's a name. It doesn't seem to be a word, but yeah. Oh well. So, you know, A, B, C, D, E, F, G is fine, right? Okay. All right. So anyway, cool. So what about lists? So I was hinting that it works for lists too. So let's see how it works for lists. So how does it work for lists? And the answer is, it just does. No, okay, so let's say you have a list of numbers, and I'm always making my variable names really long today. 1, 54, 2, 9, 18, that's clearly not 18, but whatever, 21,399, and 5. Okay, so yeah, I mean, this is basically doing it's basically doing a for loop. I can even show you how the for loop is working. So for instance here, if you have a substring equals test, and the big string is, say, find test in here, in me, then what it's really doing is it's saying for, say, I in range len big string, right? And it's saying something on the order of sub index equals, say, -1, and then we'll say, you know, if, actually what it's really doing is something more like this. It's saying found equals false, and then we're going to do for j in range len substring, and thanks for fixing my spelling pie charm, if big string I plus j is equal to substring j, let's say subfound equals false, or subfound is equal to true, and then if it's not equal, it'll set it to false, and then if subfound, we'll set found equal to true. And that's it. So that's what this for loop is doing, right? It's basically counting through the indices. So you'll have to actually look at this and understand what this is doing, right? And of course here, we might actually have to do something like length of big string minus length of substring, like +1, just to make sure that it doesn't have any kind of errors or whatever. So then we print out is found true. And then let's change it to ASDF. Is found true? No. So this is basically, for strings, this is basically what in is doing. Okay? It's probably using a much more advanced string matching algorithm, because this one is actually moderately inefficient. This one is very inefficient. It's probably using like KMP or something with, you know, more advanced string matching. KMP is short for Knuth, Morris, Pratt, which is a string matching algorithm. Okay. But okay, how does it work for lists? So basically it works the same way. We can say if, for instance, 5 is in a list of numbers, we say print 5 is in there. right? So it'll work the same way as it does, right? Else print, say 5 isn't. And of course, I don't use that because I need to use that. So if I delete 5 from the list, then it'll say 5 isn't in there, right? Okay, so this is how it works. Let's say that we have a list within a list. So if we have, for instance, a random list equals, say, 1, 2, 3, and then we have, say, 4, 5, 6, and then we have, say, 7, 8, 9. So we have some numbers, and then we have 2 lists within this list. So the first thing to go over is, what is the length of this list, right? What is the actual length of the list? And let me explain to you why the length of the list is 1, 2, 3, 4, 5, right? Because these lists count as single elements within the list itself. So if you have a list within a list, it counts as one element of the bigger list, right? Yeah, it's kind of some discrete math. Yeah, sure. So the length of this list is 5. And so anyway, if we do this again, only this time we say if 5 is in a random list, it's actually going to print out false. And let me show you why it does that. Because what it's going to do is it's going to search this one. It's going to say, are you equal to 5? No. Then it's going to say, are you equal to 5? No. Then are you equal to 5? No. Does it look within a list within a list? It doesn't know to do that. So it just asks, is this list 4, 5, 6 equal to the number 5? The answer is, this is a list, this is a number, it's not equal, so it skips it. Even though you say, but wait, 5's in there. It doesn't care. It just asks if this particular list is equal to this number. Exactly. It sees the list as a single element, not as a collection of elements to unpack. So in, basically, what I'm saying here is that in doesn't unpack anything, right? It just checks exactly what it sees. So could you ask it to look in the substring? Not really. I mean, I guess it depends what you mean by that. So I'm going to make it even more on the nose of what it's not doing. So is a list containing the element 5 equal to the number 5? And now this is a terribly, very discrete math thing, because it's asking, like, is the set containing 5 equal to the number 5, right? And let's check to see what Python thinks. So Python thinks that the list containing 5, so what Python thinks is that 5 right? So Python doesn't think that these two objects are the same, right? Python doesn't think so. And it's a good thing in a sense, because otherwise you could end up really with bad conditions where you would accidentally make a list, right, equal to a number, stuff like that, like things that really shouldn't be happening. You could accidentally do if you weren't careful. So Python does not think that 5 is equal to the list containing 5. And it's the same thing in mathematics. The set containing 5 is not equal to the number 5. And for instance, like the set containing, right? The set containing 5 and the number 5 is not equal to, for instance, the set containing 5 and 5, etc. Yeah, I think so. 5, 0, right? So at random list, yes, okay, so it's at 2 positions, right? So it's at 2 positions. So you can either print out a random list, so you were right the first time to say 3, 1, or a random list 5, 0, right? Because now it's at this position here, and it's at this position here. right? Oh, could you ask it to look inside the sublist? The answer is not within itself. If you want to do something else, there's other ways to do that. So notice that both of these things are equal to 5. Okay, so that's in. If you ever want the opposite of in, the good news is that that's in Python too. You can say if 5 is not in 1, 2, 4, 8, 16, 32, you print out 5 is not a power of 2, right? Oh, else. Actually, we don't need the else because it won't execute. So, so notice here that if you want the negation of in, you can just say not in. And that's the nice thing is that Python is really doing us a favor here, because this not in thing is both Pythonic and also English-ic, right? So is Pythonic supposed to be capitalized? Anyway, so the point here is that if you ever need the negation of in, there's a not in operator, and it's just spelled not space in. That's literally it. So this is really useful for a lot of things. For instance, when we have you doing, any kind of. So for instance, if you've added a bunch of stuff to a list, so let's say while s is not equal to quit, and let's say s is equal to input tell me animal, and then we'll say list of animals. Actually, let's just call it animals, because I've been doing too much bad variable naming. I keep wanting to spell it A-N-U for some reason, animals. So remember, basically, if you ever want to be safe about removal, so let's say, let's see. So watch this. So we say equals input tell me an animal, right? And then what we'll do is we can actually print out maybe you guessed something in our list. Keep guessing, right? So let's just see what this does, right? While animal in animals. So, and then I did input it, so we won't have an infinite loop. So if I didn't do this, right, we would get an infinite loop. Let's see what happens here. So tell me an animal. Giraffe. Kangaroo. Rabbit. Fox. Squirrel. Raccoon. Dog. Cat. Mouse. Chimpanzee. I hope that's how you spell it. And quit. Goose. Quit. So tell me an animal. So let's say I guess rabbit, right? That's in our list. Squirrel, dog, cat, and then I guess Wolverine. And then what is it going to do? It's going to break out of the... I shouldn't say break, but it's going to exit the loop, right? Because animal is no longer in the list of animals. So that's what it's going to do. And so that's... this is a pretty convenient little thing to do, right? This is something that you might find useful in the future. Yeah. So what else should we do? So we've gone through all that. I think the last thing that I wanted to talk about was concatenation of strings. So let's just talk about concatenation of strings. So remember that this is like me officially saying this, so this is the official notice. you can concatenate. And so what that means is that you can use the plus sign or plus equals to add strings together. So for instance, let's say let's do the same thing here. Let's actually tab all this in so it's in the if false block so that it doesn't run. And then let's steal that while loop here. And let's so let's do something silly like this. Print out total string, and then we'll do total string plus equals s. So sure, we can even leave it as tell me animal. It doesn't matter, right? So let's see what happens when I do this. So let's start with Wolverine, and then rabbit, then dog, cat, squirrel, fox, mongoose, snake, or let's say, what was it, viper, chipmunk. That's very good. And you see that every time I do this, right, what it's doing is it's taking the total string and it's concatenating, meaning just adding on. Concatenation is just a fancy word for adding. And so it's adding on the string that we type as a string at the end. Yeah. Oh, Python. That's an animal. Ruby is not an animal, but Ruby is a great language. Java is not an animal. Yeah. Elephant. And then we're gonna just quit, right? So basically, you are permitted to use the string concatenation whenever you want to add strings together. So you can do that inside of print state. You can even do that inside of input statements. So if you need to add, for instance, say we have, right, my name is Eric, and then we say, what is your favorite color, right? My name. You can't use the commas here because it doesn't take multiple arguments. It's a little bit finicky, but you can do this, right? You can do this. Or, if you're a real Pythoner, you can do .join this, right? So those are your two ways to do it. So these are like the two ways to handle that kind of thing. And let's actually revert this back to the string concatenation. Cool. And then let's put this to fav color, and then, you know, fav color. Let's say least favorite color. How do you add spaces between concatenation? The only way to do it is to put a space in the string, or alternatively, you can even just add a new string with a space in it like this. So that's how you have to do it. It's not pretty. I agree. It's not pretty. But it is what you have to do. So I guess we can put this in here. And then we will just run it. Tell me animal. I think quit is in order. And then what's your favorite color? Eric. Red. And what's your least favorite color? Green? I mean, you know, I don't know if those are the right answers, but red and green are two colors. So that's basically how you would have to do this inside of an input statement. Inside of a print statement, you can do, what is your favorite color? My name. Question mark. You can do these commas. The reason why you can do the commas here is because print takes multiple arguments, whereas input takes exactly one string. So this one takes multiple arguments. Input takes exactly one string. So whatever goes into input has to be made into a single string. So you might say to yourself, but wait, this is like 4 strings. But the secret is that all these concatenations happen before the input function is called. So Basically, oops, let's see. Hopefully I haven't lost internet. Hopefully I'm still good. Looks good. Okay. So basically here, what is your favorite color? All of this gets combined into a single string before it gets passed into the input function. The same thing here for this join. Everything gets joined together before it goes into the input statement, and then for your least favorite color. Okay. I think we've talked about strings today, right? Hopefully you have some better understanding of how strip, split, and join work, and we're going to use them basically for the rest of this class. They're going to be extremely fundamental objects for the rest of this class. Because, yep, I guess I should put my name here so it's not an error. There we go. All right, so I'll upload this code to the GitHub. I think that's it for today. Before anything goes really terribly wrong and my internet dies or something. Hopefully everyone found this lecture to be useful. Okay. I will talk to you guys next time, where we'll finish up with strings. I think we might do slices. I guess we'll talk about functions next time. So next time, I shouldn't say that. Next time, functions. Okay? So we get to actually do functions, and that's really exciting because functions are really the last major component of this course. And they're the major, if you know how to do for loops, while loops, if statements, print and input, and functions, then you should be good for the rest of the class. Everything else in the class is based on those things. So, anyway, next week is functions. I'm very excited. Hopefully everyone else is. All right. Outro time.